quite nice. And what have I got on there? Well, I've got a few things, and some numbers that don't mean anything to me and so on. But I'm not too worried about that for the time being. I've got the oscilloscope screen up by double clicking on it. Nothing's happening. No wiggly lines, no bright colours. It's all very boring at the moment. How do I make something happen? Well, if you look towards just to the left of the centre of the screen and the bottom tab there, you'll see that there's a green triangle. See it? See it on your screen? I'm wiggling my mouse about so that you can try and see it up here. See that green button? Press it. And something's happening on the screen. I can see some red lines, but I can also see that those red lines are much, much too big. Okay, I'm a bit confused about that, so I'm going to press the stop button to stop my simulation. But I ran a simulation. But look at my circuit. What have I got here? Well, 120 volts RMS. Quite a high voltage. It's up to you when you test circuits like this, the type of voltage that you're going to put in for an AC waveform. I myself prefer 1 volt. I like living in the world 1. Nice simple number to work with. Some people like 5, some people like 10, but whatever your preference, dial into here. So I'm going to say, if I double click on this now, and it opens up another window there, and it says voltage RMS at the top. I'm going to highlight that and put 1 in there. So now that becomes a 1 volt peak to peak, so 1 volt RMS, root mean square, a 1 volt RMS AC sine wave signal that's going in there. I then click OK. You'll notice it's changed on here to 1 volt. It's still at 60 Hertz, we'll deal with that in a minute. And I'm going to go and press the green play button again. And something's happening now, isn't it? So that seems to be a sensible height. But I can fill more of the screen by going down here. You see where it says channel A, and it says scale. If you click in that scale there, you can alter the scale. So I can move it down to 1 volt. And you can see it's a little bit above 1 volt. Well, that's because it's RMS. It's not triggering very well. I won't confuse you with the trigger for the time being. So what's our circuit doing? We're putting 1 volt RMS in, and it looks pretty much, you're going to see it on your screen, you can't really see the output waveform on the projected screen. And you've got pretty much the same signal coming out that you put in. Okay, verify that for yourself. I'll just give you a couple of minutes to work through that and have a little play with the oscilloscope itself. Make sure you're comfortable with using the scope.
When you change the voltage, you have to stop and start.
Oh yes, thank you. I didn't.
If any of you are making the change but not stopping the simulation, you won't see the new waveform.
Yeah, that's very important. You
Always
must
stop the simulation
Yep.
with the red button.
hit the red button.
You hit that one. And then when you restart it now, you will then see the refresh the waveform. That's it. So you haven't changed your voltage yet. So if we go into
Okay, if you're unhappy at that stage, let us know. We'll come and try and help you.
leave with just one there, that's fine.
It's important you get these for early stages, and then things become a lot easier when you start
So
doing
you then press the
much more complicated things.
So that's how to change that, which is fine. And then restart.
Okay.
But here,
So-
you've got 5 volts here, and we need to just make that.
As Mike very kindly reminded me, if you look on the oscilloscope, the triggering mode, now, all triggering is what voltage level does the oscilloscope start doing its analysis at. And before it had none in the bottom right hand corner of the scope, so when I run it, it looks like this. So it's what we call a travelling wave. You can't really see it or measure it or anything like that. But if we click on normal, you'll find that it's now stationary relative to us, so that we could actually measure its distance between peaks, its amplitude, all of this kind of stuff, phase shift if we needed to, and so on. Okay? So it would appear that 1 volt RMS is obviously going to be more than 1 volt of 2 volt, 1 volt peak to peak or 2 volts peak. But this circuit we've just built, effectively what we put in we get out. What a useless circuit. But remember on the board there that I showed you, if you put low frequency in, what happens? You got out what you put in. If you put high frequency in, what happens from that graph on the board? You're very shy, you lot, you know. You don't talk to me.
It simulates. It goes the low frequency, the more the distance they go, the amplitude goes out.
Yeah, thank you, Bruce. So, what happens at higher frequency? The amplitude should decrease. Now, I'm going to do another experiment in a minute, but I just want to show you how you can do this by hand. So, what I can do inside here is I can double click on this one here. Now, I made the mistake that Jane pointed out earlier. I didn't stop my simulation, so I've got to press the stop button. So my simulation is now over for the time being. I'm going to double click on my AC power source and what frequency shall I put in there? Let's have a look at the components, 1K and 1 microfarad. So on the frequency setting on there, I'm going to put a ridiculously large number, well it's not actually, it's a ridiculously low number, but 100,000 hertz I'm going to put in there. I could put 100k, but I'm just going to put 100,000 in there, just so you can see the numbers. So 100,000 cycles per second. I'm going to rotate that and I'm going to run my simulation again. What do I get? I get a straight line. How can I get a straight line? I'm putting an AC signal in there. But remember what I told you on there. That what happens at high frequency, the capacitor is short circuit. So if the capacitor is short circuit, all I can possibly see at the output is the ground, right?
Yes.
So now we see the magic of components that behave differently at different frequencies, and that's what a capacitor does. So let's stop the simulation now and let's go for a lower frequency. So let's put 10,000 hertz in there. Okay. Start the simulation. Pretty much the same result. I can't see a great deal there, but I think if I go into here and change the size of graduations, and I need to change the time frame as well. Probably not the best way to do this actually.
I've noticed when looking at your circuits, they're perfectly fine circuits, but they haven't got the same values of capacitor and resistor that John has. So obviously when looking at John's signal results, if you haven't got the same values as John's, yours will react differently.
Yours will behave differently, that's right, but that doesn't matter,
That
doesn't
doesn't mean
it?
they're wrong, they're just different.
Okay, so you still a straight line, because the cut-off frequency, we can go into what cut-off frequency is a bit later. So now we were at 10,000 hertz, let's go to 1,000 hertz. Okay, that. It now tells me I've committed the sin again, the simulation is running. Sorry, okay, that. Stop the simulation. I've got 1,000 hertz running in there. Click the button here, and point that trigger in right. There we are. So I've got to change the time base, which is the amount of times per division. So I've got 1,000 hertz there. Now you can see that that output waveform is much smaller than the one that I put in. Yeah? So what I showed you on the board is actually true. It's quite unusual for things on boards to be true. But that dropping off as frequency increases, that circuit is going to filter out the signal, the output gets smaller. Okay, a few minutes to yourself. Play about with the amplitude of the signal generator and play about with the frequency of the signal generator and see if you can sort of guess where the amplitude is going to halve. So try a really, really low frequency to start with, 1 Hertz if you like, but try a very low frequency, see what the amplitude is. Very high frequency, in my case 10,000 was high enough to produce a straight line, and find the point at which that goes to about half. If you do. I'll give you a few minutes to play with that. You know what they're doing?
The relationship between the
Sorry?
No, it's not displaying the data as it says onto 192.1.
One volt, 1,000 pounds. Have you stopped the stabilizer?
Yes.
You stopped the stabilizer, yeah? And this is 1 nanosecond division. Now it's one millisecond division. So it's 1 nanosecond division. You're looking at such a small moment in time, it looked like a DC, yeah?
and the capacity is 1 micro.
On the oscilloscope trace, how do you change the colour?
That's what I'm trying to get at. Change that again.
Yeah.
Just green one here. Just put that.